All right, let's talk about something we use every single day, but maybe don't give a second thought to: numbers. But here's the cool part. We're going to see how one single mathematical value can actually wear a bunch of different disguises. It's this simple idea that, honestly, changes everything.
Okay, let's kick things off with a super simple question. What happens when you divide 3 by 2? You've got 3 cookies, 2 friends. What do?
Well, you see the problem, right? The answer isn't a nice, clean, whole number. In the world of just 1, 2, 3, a question like this, it just doesn't work. And for a long time, that was a huge problem. So to solve it, people had to come up with a completely new way of thinking about what a number could even be.
So that brings us to our first big idea. What do you do when the trusty whole numbers we all know and love just aren't enough for the job? Well, you need a new system, right? A new set of numbers that can handle all those values that fall between the cracks.
And here it is. The solution is what we call the numbers of arithmetic. Now, this sounds fancy, but the rule behind it is actually pretty simple and, well, powerful. It basically says any division is fair game, as long as you're not trying to divide by 0, of course. And just that one little idea, it blows the doors wide open on a whole new mathematical world. Okay, so now that we've got this awesome new set of numbers, let's get into one of their coolest tricks. It's the idea that a single value, just one number, can be dressed up in all these different ways. You can think of it like, I don't know, a person who's fluent in a bunch of languages. Same person, just different ways of communicating. To really nail this down, we're going to stick with one single problem from our source material for a bit, and that problem is 29 divided by 4. So let's see all the different outfits this one answer can put on. First up, you've got the most direct way to write it, as a fraction. A fraction is really just the question itself, written as an answer. The quotient of a whole number divided by a counting number. In our case, 29 over 4. Boom. Simple, clean, direct. But, we can also write this as a mixed number. This is basically the sum of a whole number and a fraction. So let's think. How many times does 4 go into 29? Well, it goes in 7 times, right? And what's left over? A remainder of 1. So we write that as 1 over 4. Put it together, and you get 7 1/4. Then, of course, there's the decimal form, 7.25. This is probably what you'd see on a calculator if you punched in 29 divided by 4. It's the exact same value, just written in a different language that, let's be honest, is often way easier to work with for other calculations. And for our last trick, we've got the percent. Now, a percentage is just the decimal value multiplied by 100. So you take that 7.25, multiply by 100, and you get a whopping 725%. It sounds massive, I know, but believe it or not, it is the exact same value as that simple little 29 over 4 we started with. So here's the absolute key takeaway, the most important thing to get. 29 over 4, 7 1/4, 7.25, and 725%, these are not 4 different answers. They're just different languages. The language of fractions, the language of decimals, the language of percents, all telling the exact same mathematical story. Okay, so these new numbers are super flexible. Got it. But they also come with their own unique operations. You can think of them like special recipes that go beyond the basic addition, subtraction, the usual stuff. Let's check out a couple of them. First up, let's talk about the average. The source defines this as what's called a binary operation, which is just a fancy way of saying it takes 2 numbers to work. All you do is add them together and then divide that sum by 2. It's a really clean way of finding the exact middle point between 2 values. So, to see it in action, let's find the average of 75 and 87. Okay, step 1, add them up. 75 plus 87, that gives us 162. Step 2, divide that by 2, and we get 81. Simple, right? But it's an incredibly useful tool. All right, here's another operation for you, the maximum. This sounds complicated, but it's really just a formal way of asking a super simple question. Which number is bigger? It takes 2 numbers, let's call them A and B, and the answer is just whichever one of them is larger. That's it. Now, this gets really interesting when you're dealing with fractions. Like, which is bigger, 2/3 or 3/5? You can't just look at them and know, right? So as the slide shows, the trick is to get them speaking the same language by finding a common denominator. In this case, that's 15. Suddenly, our tricky problem becomes a super easy one. Which is bigger, 10/15 or 9/15?
Well, that's obvious. 10/15 is bigger, which means our original fraction 2/3 is the maximum.
So we have these flexible numbers, we have these new operations, and that's all great, but what's the point? Why does any of this actually matter? Well, let's put it all together and see how it helps us solve a real-world problem. Okay, here's the scenario, pulled right from the source material. Picture this. A school's got 66 students, they're all excited for a field trip, and each bus can hold exactly 33 passengers. Seems pretty straightforward, doesn't it? So the question is simple. How many buses does the school need to get for the trip? What does the math tell us to do? Well, the pure math here is about as easy as it gets. You take 66 students, you divide by 33 seats per bus, and you get a perfect whole number, 2. So 2 buses. Easy peasy. But hang on, this is where it gets interesting. What if just one more student decides to go? So now we have 67 students. Your calculator will tell you the answer is something like 2.03, but you can't have 0.03 of a bus, right? You can't call up the rental company and say, yeah, I need 2 buses in like the first 3 rows of a third one. This is where pure math slams right into the real world. And this brings us to the most important part. In the real world, the solution isn't 2.03. The answer is 3. You have to round up. What you really need to find is the smallest whole number that is greater than or equal to your calculated answer. That one extra student needs a seat, and that means you need an entire third bus. Context is everything. So let's just do a quick recap of what we've covered. We started with a problem. Division with whole numbers just doesn't always work. The solution? A whole new set of numbers we call the numbers of arithmetic. We saw how these numbers can be written in all sorts of ways, fractions, decimals, percents, but still mean the exact same thing. And maybe most importantly, we saw that a raw calculation isn't always the real-world answer. You have to know how to interpret it. And that really leaves us with a final question to chew on. Math gives us all these incredibly precise tools to find the right answer. But at what point does knowing how to interpret that answer become the most important skill of all? It makes you think, doesn't it? Thanks for tuning in.